south of the province of Lleida, close to the French border, are the three valleys of Tavascan, Lladorre and Ferrera. This region contains a variety of glacial lakes, such as Certescans, which is the largest in the Pyrenees and one of the deepest. The waters descend from the three valleys and feed the hydroelectric complex of Cardós. The altitude of the heads of these Pyrenees rivers means that they are excellent for efficiently producing hydroelectric power. The power station at the cavern of Tavascan was inaugurated in 1971 and has two Pelton turbines driven by a water drop of 900 meters, one of the highest in Europe. The flow rate is 14 cubic meters per second, producing a maximum power output exceeding 120 megawatts. At the same power station, there is a third generator, a vertical axis Francis turbine and a drop of approximately 250 meters. The turbine is driven using water stored in the Grouse Reservoir. With a flow rate of 14 cubic meters per second, it can produce an output of 32 megawatts. In 1974, the recovery power station of Montemara was inaugurated, one of the first hydroelectric pumping stations on the Iberian Peninsula. It is also underground and located 250 meters above the power station at Tavascan. It has two vertical axis Pelton turbines, each with a pump of 4 stages, coupled to the same axis as the turbine to enable the pumping operation. It makes use of a large part of the Tavascan drop, some 626 meters, generating 88 megawatts or consumes 110 megawatts when acting as a pump. The total Tavascan-Montemara water drop is comprised of 5 hydraulic groups. 2 of them include pumps, with a total installed capacity of 288 megawatts. Initially, the Tavascan-Montemara waterfall system was designed to function using local operation. Thanks to advancements and improvements in the reliability of new technologies, the system became remotely managed from the Hydraulic Production Control Center located in the city of Lleida. This first automation of the plant has gradually become outdated, and now it is imperative to modernize, optimize, and simplify the entire functioning of the system, from the chains of the relays to the machinery governed by the PLCs. The most critical part of the modernization is the planned intervention to the tunnel that connects the 2 power stations. This tunnel has a length of 400 meters and a gradient of 85%. It houses the reinforced pipe of the inferior part of the Tavascan drop, the power cables, the cables for communication and control, in addition to the service staircase. Due to environmental conditions in the tunnel, there has been some considerable deterioration of the construction materials, such as the support structures of the power cables, or of the insulation materials of the medium voltage conductors. It is therefore necessary to carry out various improvements, among which are waterproofing of the tunnel using impermeable materials, replacing the structures that support the power cables, as in some areas they are already in an advanced state of oxidation, replacement of the medium voltage cables, groups 1 and 2 Montemara, updating the drainage system and the supports of the reinforced water pipe, replacement of the emergency lighting. These improvements are part of the action plan to modernise the entire Tavascan-Montemara hydroelectric complex envisaged for the period 2014 to 2020. To undertake this modernisation, an action plan of different phases with the following chronology has been proposed. Carry out the engineering and work of the automisation of the Tavascan-Montemara complex. Adapting the installations of the 220 kilovolt park to the new technology. Adaptation of the automated equipment of the power station, updating the cooling system, wells leak management, ancillary services, distribution of AC and the distribution of DC. Waterproofing of the tunnel link and replacement of the medium tension cables for Montemara Groups 1 and 2. And finally, automisation of the generators and power transformers of the Tavascan-Montemara complex.